Okay, now, just to make sure that you guys know I'm not lying to you, check this out. I'm going to show you how to put this on your calculator. Let's make sure, because this can get a little tricky, especially with things like cotangent, secants, et cetera, et cetera. But let's go back here. So remember, if I take the inverse sine of negative 1/2, let's see what happens. So I'm going to hit second, I'm going to hit inverse sine, and then I'm going to go negative 1 divided by 2 and print them. Let's see what happens. So it's going to spit this out. Now, I got to be real careful here. Let's check this out. Let's go to our mode. It's in radian. Now, just for giggles, even though I don't like to take it out of radian if I can help it, I'm going to put it in degree. Okay? Now I'm going to quit. Excuse me, I'm going to quit, and I'm going to go second entry because it'll just give me the same entry, and I'll hit enter, and look at what it gives me. It gives me negative 30 degrees, which is negative pi 6. Again, the biggest problem with that is that it ended up not being in the interval, so I had to jump around a little bit. Okay? So remember, when in doubt, check your mode, check your mode, check your mode. So I'm going to put this sucker in radians just so it's there, and I'm not afraid, right? And remember, because when it's in radians, if I know that it's negative pi 6, then I just want to double check to put my mind at ease. I can always just go, okay, negative pi divided by 6, and oh yeah, it's the same answer. Now, the cotan one is a little trickier because remember, the place where I like to start messing around with my inverse cotan, because notice my calculator doesn't have an inverse cotan on it, and it's not 1 over this. We got to be really, really careful. Watch. Do you agree? Let's do this in blue so we can draw attention to it. Do you agree that if I have that the cotan of theta is equal to negative root, negative root 3/3, which remember this was just negative 1 over root 3. Well, that's exactly the same thing as when the tangent of theta is equal to negative root 3 because they're reciprocals of one another. Okay? So you got to be careful when I go to figure this out, because I know that this is going to give it to me at 2 pi thirds. When I go to figure this out, I have to make this conversion here because my calculator doesn't have an inverse cotan on it. So I'm just going to go second inverse cotan, and I'm going to have negative second root 3 in paren. Oh, I hate this new OS. I screw it up all the time. In paren and booyakasha. Oh, negative 1.047. Again, I could change to degrees, or again, I could just go, okay, let's see, 2 pi thirds, and then, of course, I'll have a negative in front of this, but it's the same. 2 pi thirds. Oh, wait, it's negative. Oh, what did I do? Remember, the true value that I should have gotten was negative pi thirds, right? That's what it's going to give me because arctan. This is where it gets even more confusing. The domain of arctan is from negative pi halves to pi, or excuse me, negative, yeah, what am I saying? Negative pi halves to pi halves. Remember, inverse tan only spits out values from here to here. So what this actually gave me was, watch, I'll show you, negative, I'm glad I stumbled onto that. I forgot about that. Negative pi divided by 3. Negative 1, see these two guys right here? They're the same. If I add pi to this, I get to the other. That makes it even more convoluted and confusing. So the idiot box, go to your idiot box dead last. Work from the mother graphs and what we know about the unit circle first. Because otherwise, this thing's going to spit out numbers that you don't have any idea what it's doing. Now, if we had an inverse cotan on here, it would have spit out 2 pi thirds because the range of inverse cotan is from 0 to pi. Remember that it was the same as the inverse cosine. Okay? All right, well, let's play just a little bit more. I'll do a couple of these for you, and then we'll be done. Okay, let's do, oh, I don't know. I need to make up a good one, don't I? How about this one? Let's try this one. How about cosine? How about the cosine of 2 theta equals root 3 halves? All right. Now, what do you notice here? By the way, this is the angle. What do you notice? All right, we got to be real careful. Let's do this for all reals. We're going to do it for both, but let's do it for all reals first. Okay. So relatively easy to solve for, right? Not a problem. I know that 2 theta is going to equal the inverse cosine of root 3 over 2. Now, think about this for just a sec. We're going to do all of it. Here's my unit circle. All students take calculus, right? But I'm also going to think about cosine in terms of its mother graph. So I'm going to do this guy. All right? So root 3 over 2, what is that? All close to 3/4, right? So I'm going to call this root 3 halves, and then, oh, that's right. Remember, cosine's positive in the first and the fourth quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. So the places where root 3 over 2 is slamming into cosine is here in the first quadrant and here in the fourth quadrant. But I'm not afraid of that, right? That's no problem. So the values that I get for this, I'm going to come down. 2 theta. Let's see, the inverse the cosine of what angle is root 3 over 2? Oh, that's easy. That's pi 6, right? But it's also negative pi 6. See that? Now, let's be real careful here. We got to be really, really careful, because if I know that 2 theta is actually going to equal, remember the inverse cos of root 3 halves is going to be pi 6, but that's going to happen every 2 pi k. It's also going to happen at negative pi 6 plus 2 pi k. Remember that k is just an integer. It could be positive or negative whole number. Now when I divide through what I get, so this is a solution, but I'm not solving for 2 theta. I don't care about 2 theta. I care about theta. What I get is pi 12ths plus pi k. And I also get negative pi 12ths plus pi k. Now you may ask yourself, wait a second. Ripley, I thought that the period of cosine was 2 pi. It is. But the period of cosine of 2 theta is, remember, the original period divided by the coefficient, which is pi. And that's why this happens. All right? It gets crazy. So basically what happens is we use the inverse cosine on the regular old y equals cos theta, to come up with these values. And then we have to divide through by the 2. That can get really confusing. It gets even worse. So now we're going to take our time on this one. What if I want to go from 0 to 2 pi? Let's think about that. Okay? So I'm in exactly the same situation here, right? So I know that 2 theta is going to equal the inverse of root 3 over 2. Okay? So this I know is going to equal 2 theta is going to equal, now I'm going to get a little cheesy here. I'm going to get pi 6 and negative pi 6. Now if we're not really, really careful here, we might say, oh, that's easy, Ripley. That just implies that theta equals pi 12ths and theta equals negative pi 12ths. Well, my spidey sense is already tingling because negative pi 12ths ain't in this interval, right? So here's what we have to think about. There's a number of ways to do this, and I'll show you all of them. Remember, if I do y equals cosine of 2 theta, that tells me that I'm going to get my cosine to do 2 full laps from 0 to 2 pi. So now this is pi, and this is 2 pi, right? And I'm looking for when this guy slams into root 3 over 2. So it's going to hit it once, twice, 3 times, 4 times. I'm going to have 1, 2, 3, 4 solutions if this is root 3 over 2. By the way, I should probably put y equals 0 in here, right? Okay, there we go. So guess what we just solved for? We solved for pi 12ths, right? The question is how do I solve for these other values? Well, there's lots of ways to do it. The first one is think about the period. If I want to get from this point to this point, since the period of cosine of 2 theta is pi, I can just add pi to it. So I know that I'm going to get theta equals pi 12ths and theta equals pi 12ths plus pi, right? Which is affectionately known as pi 12ths. And what is that? 12 pi 12ths plus 1 is 13 pi 12ths. Now the other value is a little bit trickier. Okay, this guy's trickier. However, with a little bit of dirt work, we can think about it a whole bunch of ways. But for me, the easiest way is to think about it as this. I know that this guy gave me negative pi 6, which is not going to work on the interval. However, because that would give me, think about that, wouldn't that give me this value over here? This value, let's change colors. I'm getting a little too crazy with this diagram. This value is negative pi 12ths. Right? I'm sorry, not negative pi 6. That was when it was 2 theta. It's negative pi 12ths. But again, the period of cos of 2 theta is pi. So I'm just going to add pi to get to that one. So I'm going to take this, and I'm going to add pi to it. If I want to get from here over to this guy right here, well, what's the period of cos 2 theta? It's pi. So I add another pi. So I can go negative pi 6 plus 2 pi, or whatever this guy was, plus 1 pi. All right? So let's see. Wait a sec, negative pi 6, somebody's got to yell at me. Those are supposed to be pi 12s. Sorry about that. See, there's a lot to keep track of. I'm sitting here doing it, and you do make errors. You have to back yourself up rather than re-edit the whole thing and make me appear perfect, which everybody knows I am. Just kidding. It's good to see those. So let's see, 12 pi, so what's that? 11 pi 12ths is this guy. And then add another 12 pi 12ths to that, and we're going to get 23 pi 12ths. And these, this, and this are all my solutions. Now, excuse me, check it out. Let's make sure. Let me give you one quick warning. Just to be smart, when you get your solutions, double check to make sure that they're in the interval from 0 to 2 pi. All right, we want to pay attention to that. So pi 12ths, definitely. 13 pi 12ths, that's 1 and 1/12 pi, that's for sure. 11 pi 12ths, that's slightly under 1 pi. And then 23 pi 12ths, that's slightly under 2 pi. Cool, we got them all. That's awesome. Now, let me show you another way to check your work. This is the hard part. You really have to, you got to go easy when you start bringing too many tools in. It's kind of like, you know, how, what is it, too many chefs spoil the broth. Well, we can run into that problem here as well. I'm going to skate back out, and let's put it in our calculator. Watch this. I'm going to go y equals, let's see, let's clear these out. So we have this and this. So what did we say? We said that the cosine of 2 theta, so the cosine of 2x, which is what they're going to do. And then we said root 3 over 2, right? So second root 3, and then I got to do this funky thing, divided by 2. Now I'm going to graph them simultaneously, but I'm going to tweak my window just a little bit here because I don't want negative 10 and 10. Let's go from negative 2 to 2. And then let's go from 0 to 2 pi. Let's make sure that what we're talking about here is actually accurate. So I'm going to go from 0. In other words, I'm putting in my window the exact same values that are on my interval that I need to solve for. And I'm going to, double check your mode. Oh, whew, we're in radians. Perfect. So I'm going to graph it. Whoa, what did I do there? Let's try this again, because something hoopty happened clearly with my window. Did I go for my X-Men? Oh, God. I went the wrong way. Sorry, 0 to, what a ding-dong, to 2 pi. See, we make mistakes. And then y-min's going to be from negative 2. Maybe I should redo that, re-edit it. Nah, we'll see. I don't know. You'll find out shortly. So there's that. Look at that. There's some 0 to 2 pi. And we have 1, 2, 3, 4 solutions. Let's solve for one of those solutions, shall we? So let's go second calc, and we're going to find an intersection here. So I'm going to move this kind of, let's go for this guy, because we know that this guy has to be 11 pi 12ths, right? So I hit enter on my first curve, then I toggle down, and I hit enter on my second curve. Enter. Did I hit it? Enter. Wait, second, maybe it didn't toggle down. There we go. Enter. Guess. I don't waste my time. My intersection is at 2.879. That doesn't really help me. However, let's look. 2.879, what did we say? It should have been 11 pi 12ths, right? So 11 second pi and divided by 12. And let's see if it gives us the same value, 2.879. Look at that.